Hello children. So today we are going to discuss about chemical reactions. I am Dr. Manjulatha and I am going to deliver a lecture on chemistry subject. So for 10th grade students. So today's topic is all about chemical reactions. So before starting the topic, first we need to understand some things that we daily observe in our daily lives, right? So in our kitchen itself you will be observing so many things. So in summer, hot summer, if you leave milk outside without boiling the milk, if you keep it like that, definitely after some time the milk get spoiled. So it will be converted into curd form, and we cannot eat, we cannot drink that milk. It will be very hard. So what happened behind that? So some chemical reaction happened over there. Similarly, if you take a iron tawa, okay, and after cleaning with water, if you leave it like that for some time, definitely you are going to observe a brown color layer on the tawa. So what is happening to tawa? So because iron is getting some chemical reaction with some materials in the atmosphere, and that rust is getting formed, right? So grapes fermented. So if you keep the grapes outside for some days, they will be after so many years they get fermented, and you can use to prepare wines, right? So food is cooked. If you are cooking a food, you will take so many ingredients are added to the food and you apply some heat, right? So some chemical reaction is going to happen and it is converted into a prepared food that is ready to be eaten. So raw ingredients anyway we cannot eat, so we add different ingredients and we prepare very delicious food. So this is also another example of chemical reaction. So another things, if you observe our human body, human body is also very complicated system. So many things are going to work in our body. For example, if you take digestive system, so in the digestive system also, once we eat our food, it will be processed in multiple ways. So first the digestion starts from our mouth itself. We need to chew it properly and it will be transmitted through the food pipe, and then it again reaches the intestines. There are so many things, that so many acids, bases are added, and food is processed in the digestive system. So here also we can say so many chemical reactions are going to happen inside our digestive system. And once those are completed, the waste things will be excreted from the excretory system, and the required good things are converted into energy, and that is supplied to our body. So this is in brief, but it is behind this very complicated process you can observe so much of chemical reaction, right? And coming to respiratory system also, so we are breathing with our nose. So what is happening after taking the air into our body, how it is going to help us, and how oxygen will be supplied to all the cells in our body, and how the carbon dioxide is taken out, right? This entire process is again behind that. If you observe, there is definitely some chemical reaction is going to take place. So to understand these chemical reactions, we can do some activities, how it is going to happen. So in this figure you can observe, so here we have taken magnesium ribbon. So using the magnesium ribbon, what we are doing, in the laboratory you can perform this one. So 3 to 4 centimeters long ribbon we are taking, okay, we are cleaning it with a sandpaper, okay, and we are holding that paper using a tongues, and we are burning it using a spirit lamp, okay. And here again we kept one Here you can observe. So here right. So as shown in the figure, here what we are doing, we are taking a using in the laboratory, using the burner, we are holding a magnesium ribbon, and we are burning using this flame, right, spirit lamp, using the spirit lamp. And here we are having a watch glass, so to collect the ash formed in the during this process. So here what you will observe, after burning this magnesium ribbon for some particular time, after some time you will find white color ash in the watch glass. So that white ash is, what is that? You will say it is magnesium oxide. What is this magnesium oxide? From where oxygen came into picture means, so when we are burning this using the flame, so in the air we are having oxygen, so our magnesium ribbon, magnesium is getting reacted with the oxygen, and we are having magnesium oxide as the result over here, and that is getting collected in the watch glass. Okay, right. So to understand this chemical reaction, we are given different activities in our textbook also. So first activity, we are taking a magnesium ribbon, and we are using the flame. We burn that ribbon, and after some time what is happening? A white ash is getting produced, which is nothing but magnesium oxide, we are telling. So here some other interesting activities are there. These things you can test in your lab if possible. So in the second activity, what we are doing, we are having lead nitrate solution. We are taking a lead nitrate solution in the test tube and add potassium iodide solution to this. So what is happening? If lead nitrate is taken in the test tube, and we are adding potassium iodide solution to that one, what is going to happen? So in the activity 1.2, so what they are doing, they are taking lead nitrate, and they are adding solution potassium iodide to that one. So then if you observe, this type of reaction is known as the precipitation reaction. So here what happens, these two will be having a chemical reaction, even you can observe in the lab. So you will have a yellow precipitate will be formed after some time, and that yellow precipitate is nothing but lead iodide. If you observe, lead is here, Pb is nothing but lead, and iodine is represented with I. So lead and iodine are getting combined to form the lead iodide, which is a yellow precipitate that is getting formed in the beaker. And a colorless solution you can form, you can see on the top of that one, which is nothing but potassium nitrate solution. So these two are getting combined, and lead is going to combine with iodine. So like this there are different types of reactions. This is one of the reaction over there. So in our lecture we will learn how to represent the reactions. So we understand the reaction so easily without explaining part, simply using a equation, how we can represent the chemical reaction. These things we are going to learn in our lecture. In the next third activity, they are telling take a few zinc granules, and we take it in the conical flask. Zinc granules are taken, okay, and conical flasks or a test tube you can take. Add dilute hydrochloric acid, you have to add to this one. You can add either hydrochloric acid, or you can add sulfuric acid. H2SO4 is sulfuric acid, and HCl is the hydrochloric acid. So if you do that one, you have to be little bit careful while doing this experiment, because it is a exothermic reaction. So exothermic means it is going to release some heat. So if you are not careful in doing this reaction, it will be hot. You cannot touch it directly. Some heat will be released over here. So that's why it is given, you have to handle this with care. So what is happening around to the zinc granules here, and touch the conical plane flask or test tube. Is there any change in the temperature? They are asking. Definitely you can observe a rise in temperature. It will be little bit hot. And what happens to the hydrochloric acid over here? So zinc is going to react with this one, and ZnCl2 is going to form over here. So zinc chloride is formed, and bubbles of gas will be released from the tube, and that is nothing but hydrogen gas. You can observe in the figure also. So it is a conical flask. They are having a glass tube here. So cork is fixed, right? So and here you can observe H2 gas is come out of that conical flask, right? So we added dilute sulfuric acid, and zinc granules are there in the beaker. So finally this is known as a single displacement reaction. So here single displacement is Z is replacing Cl from hydrogen, and hydrogen getting separated, and it is getting released as gas, you can observe, right? And zinc chloride is getting formed here. And in the second type, if you add zinc granules to H2SO4, in that case also it is a single displacement reaction, and ZnSO4 is getting formed. So Zn and SO4 are getting added, and hydrogen is getting released in the form of bubbles of gas. This hydrogen gas we can utilize for laboratory purposes. Using this experiment, whatever that hydrogen gas is released, that we can preserve actually, right? So here whenever you observe any chemical reaction, so how to represent the reaction, that is very important. So word equation, you can represent the chemical reaction using a word equation, and even you can represent with the symbolic representation also we can do. So word equation means how you will represent. For example, our first activity, we have taken magnesium ribbon. So magnesium is one of the input, and that is getting reacted with oxygen, and so these two are known as reactants. So these are the, so now that is getting, both are getting reacted, and they are getting converted to magnesium oxide. So this is the product. So we are having two reactants, and they are added, and that is shown with the plus symbol, okay? And that is getting the product is what are the products that are coming? They are written on the right side. So this LHS part is all about the reactants, and the RHS part are the products that are getting released, are getting developed after the chemical reaction. They are written on the right hand side, right? And the direction arrow mark is showing that after reaction what is going to happen, that is indicating with the arrow mark. So here it is clearly written, the word equation shows the change of reactants to products through an arrow placed between them. The reactants are written on the LHS, so left hand side with a plus sign between them. Similarly, products are written on the right hand side, RHS with a plus sign between them. So actually in this reaction only one product is there. That's why we just represented magnesium oxide over here. So this is the form of representing the chemical reaction using a word equation. So just now we discussed about word equation form representation, right? Similar way, Now can we make it more concise? That is our question. So how to make it more concise? Anyway, for every material, existing materials, we are having symbols, right? So we can show it in a more concise form as Mg plus O2 is equal to MgO. This is the representation in a concise form. Here we are representing the chemical equation using the symbols. So previously we using the word equation. Here it is represented in the form of symbols. Okay. So one more thing. So balanced, this is known as a skeletal equation. Skeletal. So what is the skeletal equation? Basically, in this they are not balanced. If you observe, magnesium 1 atom and here 1 atom. Oxygen 2 atoms you can observe, but here only 1 is there. So this is not a balanced equation. So then again we have to observe how to balance a skeletal equation. That is also very, very important. So now for a Mg plus O2 is not a balanced equation. So here why we need to balance the equation? The reason behind this is in previous classes you already learned the concept, that is conservation of mass, law of conservation of mass. Law of conservation of mass. What is this? This is the total mass. Mass can neither be created nor be destroyed. That is the law of conservation of mass, right? So whatever the inputs are taken, so same number again you have to generate, is it not? So mass cannot be created nor be destroyed, only it can be converted from one form to the other form. That is nothing but law of conservation of energy or law of conservation of mass also. So that's why always you have to take care that whatever the chemical equation that you are taking, it has to be balanced. For example, here one equation is given. We are taking right. So zinc, sulfuric acid, both are getting reacted to get zinc sulfate plus hydrogen. Just now we discussed in the second and third activity, right? So if you represent this in the form of symbols, Zn plus H2SO4 is the symbol for sulfuric acid. Both are getting reacted to generate. These are known as reactants. And ZnSO4 plus H2. This is our chemical equation. So in the tabular form, they clearly mention how to see this. So what are the elements here? Zn is there, hydrogen is there, sulfur is there, and oxygen is there. So number of atoms in the reactants, LH side, this is known as LHS, and this side is known as RHS. So on the LHS side, zinc is, how many zinc atoms are there? 1. And how many hydrogens are there? 2. Right? So, and how many sulfurs are there? Only 1. How many oxygens are there? 4. Now, number of atoms in the products. This is RHS is the products. So, these are the reactants. These are the products. If you observe this, in the product also zinc is 1, S is hydrogens are 2, and sulfur is 1, and oxygens are 4. So if you observe, they are matched over here. So it is known as a balanced chemical equation.